Good morning to all. Today we are going to see basics of clustering and one simple algorithm, k-means algorithm with a sample example. What is clustering? Clustering is a process that is used to group a set of data objects into different number of clusters or groups. Clustering is one of the unsupervised learning algorithm because here the only data points are given without giving the description or label of that. Based on that similarity of the data we have to group. Here, mostly the distance measures are used by numerical way. Next, what is the group clustering? So the clustering can be identified by two different parameters. One is intra-class similarity, another one is inter-class similarity. First, we'll see what is intra-class similarity and inter-class similarity. Intra-class means the objects after clustering, the objects within the same cluster must be most similar. And this is called as cohesive within clusters. Next one is low interclass similarity. That means after clustering the data into multiple clusters, objects between one cluster to another cluster must have high dissimilarity. And this is called distinctive between clusters. The quality of the cluster depends on three different parameters. The first one is the similarity measure, what we are going to use during clustering. And second one is implementation. It is nothing but algorithm what we are selecting for clustering. Third one is ability to discover the similar patterns. Sometimes the data value can be just numbers directly given, means we can apply the distance measures. Sometimes the data is some complicated things. From this, we have to extract the features. From the features, we have to apply the distance measure. So this hidden patterns sometimes influences about the clustering. Next, we are going to see the distance measures. So most of the commonly used distance measures are Minkowski, Manhattan, and Euclidean. So in all these distance measures, the numerical formulas are used. The difference, square root, and calculating the absolute value. So these mathematical formulas are directly used. So this will be useful for data which are numerical. Suppose the data are non-numerical. For example, the apple color is given as red and green. In such case, we have to convert the values into numbers. Then we can apply these formulas directly. For red color, we can give some common color name like color number as 111. Blue color means 2. Then red color means 3. Like that, we have to convert the words or some other labels into numbers. Then after converting into numbers, we can apply the formula directly. First, we'll see the Minkowski distance. In the Minkowski distance, the data is p-dimensional, means first we have to calculate the difference between for each dimension. First, we have to take the dimension 1. Here, objects are considered as I and j. We have to take the ith object and jth object. We have to take the dimension 1. So, we have to calculate the difference. Then we have to calculate the dimension 2. Then we have to calculate the difference. Like that, we have to calculate the difference. And for each one, we have to power by q. Q is nothing but some positive integer, maybe 1, 2, or 3, anything. Then after finding the difference, we have to apply the power. After that, we have to sum it. Then we have to apply 1 to the power q. Like that, we have to calculate the distance. Next one, if q value becomes 1, that is called Manhattan distance. It is just calculating the absolute difference. If q value equal to 2 means after calculating this sum, we have to calculate the square root. So this is Euclidean distance. So these are the commonly used distance measures. Next, we are going to see the basics of simple k-means algorithm. Here in k-means algorithm, we are having large number of data set. Here we have to divide the data set into simple clusters. Sometimes k is given, means we have to divide the entire data into 3 clusters. Here I have taken k equal to simple example 3. Here these are the entire data set. This will be splitted into cluster 1, cluster 2, and cluster 3. Now we'll see the algorithm. In the first step, we have to choose the cluster number. Sometimes the cluster number may be given in the problem itself. In such case, we can take the k values as it is. If the k equal to 2 means we have to divide the original data set into 2 number of clusters. If k equal to 4 means the entire data set should be divided into 4 number of clusters. Like that we have to divide. So if you know the k value, we have to select k number of points. For each k, we have to select one seed point. In this example, k value equal to 3 means we need 3 data points. Each data point serve as a cluster setup as at an initial stage. Then we have to calculate the distance between each point to each cluster center. Here my k value equal to 3 means I have to calculate the distance between one point to this cluster center 1, the same point to cluster center 2, the same point to cluster center 3. So based on that, I have to identify which is having the minimum distance. If the minimum distance is having means I have to assign that particular point to the particular cluster. So like that I have to assign in step 4. Then in step 5, I have to calculate the cluster center. Initially, the cluster center is random point only. Then after assigning the data point to cluster, I have to calculate the cluster center. This cluster center is calculated by calculating just mean value. As the name of the algorithm name, I have to calculate the mean for each values in the cluster. Then the new cluster head will be the mean value. So based on this, I have to calculate the distance again. I have to reassign the data point to new clusters based on the minimum distance. So this step 3, 4, 5, I have to repeat until the following criteria. If any one of the criteria is satisfied means I can stop the clustering algorithm. The first one is there is no change in the cluster head. In this case, I can stop this algorithm. The second one, all the data points in the clusters are same. There is no change in the cluster. In that case, I can stop. Then third one, maximum number of iterations are reached. Suppose in some problems, the number of iterations are given as 3, 4. In such case, if that kind of iterations are reached means I can stop. So this is the basics of k-means. Now we will solve the k-means algorithm with the following data set. Here, there are 8 data points are given. It is named as A1, A2 up to A8. Here it is given as a 3 cluster. So I have to assume k value equal to 3. So and also it's given A1, A4, A7 as a cluster center. So for the initial cluster C1, A1 is the cluster center. For cluster 2, A4 is the cluster center. And for cluster 3, A7 is the cluster center. Here, the distance method is given as a simple Manhattan distance. The difference between x and the difference between y, and all the data points are two-dimensional. So this is a sample given. So we have to apply the k-means algorithm to find 3 clusters up to second iteration. So here we have to stop at the second iteration. Now I'll solve this problem. Consider we are having 8 points. So we have to draw like this kind of table. Here cluster center. What is our first cluster center? 2, 10. Our second cluster center is 5, 8. Our third cluster center is 1, 2. Then based on the distance, I have to assign the cluster. Here I have to mention the data point. Initially I am mentioning the data point 1. So what is our data point 1? It is 2, 10. So now I have to calculate the difference between this 2, 10 to 2, 10. First I have to calculate the difference between x point, and then I have to calculate the difference between y point. Then I have to sum it. The difference between x point 2, 2 is 0. 10, 10 is 0. So the total distance is 0. Next I have to calculate the distance between 2, 10 into 5, 8. The distance between 2 and 5 is 3. The distance between 10 and 8 is 2. So the total distance is 5. Next I have to calculate the distance between the point 2, 10 to 1, 2. The x distance is 2 minus 1 is 1. The y distance 10 minus 2 is 8. So the total distance is 9. So by comparing this distance, A1 is very closer to that point 2, 10. So A1 can be assigned to cluster 1. Next, I'll take the point 2, 5. So this is the point 2. Now we have to calculate the distance between 2, 5 to all clusters. So first I have to calculate the distance between 2, 5 to 2, 10. So in x-wise distance 0, in y-wise distance 5 minus 10 is 5. So I have to calculate the distance as 5. Next I have to calculate the distance between A2 and cluster 2. In x-wise distance 2 minus 5 is 3. In y-wise distance 5 minus 8 is 3. So the distance is 6. So here the distance should not be taken as a negative because it is the absolute value. Then consider the point A2 and cluster 3 head. X-wise distance is 2 minus 1, 1. Y distance is 5 minus 2, 3. The total distance is 4. So here you compare the distance which is mentioned in the green color. The distance from point 2 to cluster 1 is 5. 2 to cluster 2 is 6. 2 to cluster 3 is 4. So the minimum distance is 4. So I have to assign the data point 2 to cluster 3. Then I have to take the data A3. What is A3? 8, 4. So now we have to calculate the distance between 8, 4 to cluster 1. So 8 minus 2 and 10 minus 4, the total distance is 12. We have to calculate just absolute distance only, not the negative. Just the difference only we have to calculate. Then A3 to cluster 2. The difference is 8 minus 5 plus 8 minus 4. The distance will be 7. Then same way A3 to cluster 3. 8 minus 1 is 7. 4 minus 2 is 2. The total distance will be 9. So by comparing all this distance, so this is very less. So point A3 will be assigned to cluster 2. Likewise, the same way I calculated for remaining points from A4 to A8. After that, based on the distance, I assigned the data point to particular cluster. So in A4, when comparing the distance, the A4 to cluster 1 is having distance 5. A4 to cluster 2 is having distance 0. A4 to cluster 3 is having distance 10. So based on that, the minimum distance is 0. So I assigned A4 to cluster 2. Like that, I have to calculate for all the points. So now we draw the cluster diagram. So in the cluster 1, we are having only one data point, A1. In the cluster 2, we are having the points A3, A4, A5, A6 and A8. Next we are having another cluster C3. It's having 2 points. So based on the previous table, I divided the data points into cluster. So initially we are having 8 data points. So after first iteration, so this is the cluster details. So now in the C1, that means cluster 1, there is only one data point. So there is no need to change in the cluster head. But here in C2 and C3, we are having multiple data points. Here we have to calculate the mean value. So in cluster 1, there is no change. In cluster 2, these are the points. So I have to take the mean value in X and Y direction. So I have to add all X value 8 plus 5 plus 7 plus 6 plus 4. So how many points? There are totally 5 points. So after adding, I have to calculate the average. In the Y direction also, I have to write in Y, I'm having this value 4, 8, 5, 4, then 9. Then I have to divide by 5. So after that, what will be the answer? The cluster 2 is having the answer 6, 6. So this is the new cluster head. In the same way, now we have to calculate the new cluster center. In cluster 3, we are having only 2 points, 2, 5 and 1, 2. So we have to add x value and we have to divide by 2. We have to add y value and we have to divide by 2. Why we have to divide by 2? Because we are having only 2 values. For average, we have to add and divide by 2. So finally, the cluster 3 is having center 1.5, 3.5. Like this, we have to calculate for every iteration until either there is no change in the data points, there is no change in the center head, otherwise the maximum number of iterations are reached.